Hi Prof, I'm Xiong and this is Taoyan, Lian, Guanlan, Xiaoqing, and Guangxu. Now I'll be starting on our presentation. For our ERD diagram, we first split all the many-to-many relationships into two one-to-many relationships with associative entities. So these associative entities are user-user, challenge list, club list, weekly leaderboard list, and user activity. So notice that weekly leaderboard list now contains the position attribute to simplify the weekly leaderboard table. So for personal best, we interpret it as the longest distance of an activity that the user has ever ran or swim. So while our activity is event-based, for example a marathon, hence any user that participated in the activity will have the same activity distance and duration. So for our MySQL queries, we mainly use 5 tables which are user-user, user, user activity, kudo, and activity. So user-user table is the list of users who is followed by another user, in other words, the followers. While the user activity is the list of users who participated in an activity. And lastly, kudo is the list of activity that a user participated in, which was given a kudo from another user.
So now I'll demonstrate how we imported our SQL package. So click server, data import. Then we select our file from this. So it's 2402 project. We open it. New. Okay. So we start import. If we refresh our schemas, here's our demonstration. Let's take a look at the activity table. So these are our data. So originally we create our data in our CSV file. So after we imported this CSV file, and here's our data.
Now I'll move on to the second part, demonstration of the relational database implementation, and I'll first talk about question tree. Question tree is to generate a list of female users who are only followed by male users. So for this question, there are two parts. So the first part is to generate a list of female users, which can be shown by this part of the code. And the second part is that followed by only male users. And this implies two things. The first thing is that the user is followed by some male user, and the second thing is that the user is not followed by any female user. So this part of the code shows that the user is not followed by any female user, and this part of the code shows that the user is followed by some male user. And now I'll run the code. The result shows that Taoya is the only female user that are only followed by male users.
And now I will continue with question 4. In this question, we're trying to generate a list of users who are following each other mutually. So it means if A is following B and B is following A at the same time, they are considered as to be mutually following each other. And now let's look at the code. So in this code, we solve this problem by inner drawing the user-user table and check whether there's a case the follower ID of table A is same to the user ID of table B, and at the same time the user ID of table A is also same to the follower ID of user B, and this will return us the users who are mutually following each other. But in this case, there's a problem because duplicate records will be returned. And to solve this, we thought of a very simple and smart way by adding this piece. User ID of table A is smaller than follower ID of table A. And by running this code, you can see it returns the pair of users who are mutually following each other with the duplicates removed.
So now we'll be talking more about question 5, which is generating activity insight for a list of users who have exercised less than 30 minutes per week, between 30 and 60 minutes per week, and so on. So firstly, we will set a variable total week by having the maximum week for the activity date column minus the minimum week for the activity date column will be plus 1. So next, we inner join the user activity table with the user table and the activity table, and then we group by the user ID. And next we select out the username, the user ID, and the activity time per week, which is the sum of the activity duration for that particular user ID divided by the variable total week. And finally, to get the part 1 of the question, we use the having function to filter through activity time per week of less than 30 minutes. So as you can see here, Gary has an activity time per week of 9, and Chen Ling has an activity time per week of 28. So for part 2 of the questions, we simply have to change the having part of the code to get the activity inside of between 30 minutes and 60 minutes.
Moving on to question 9. So we are supposed to compute monthly active social networks. So for each user, we list out his or her followers, but I've given him or her more than or equals to 5 kudos for each month activities. So since a kudo can be given by anybody, we have to inner join to our kudo table as well as the user followership table to find out which are the followers who have given him or her the kudo. So let's run the code. We can see that it's user ID 1 in September who received 5 kudos given by ID 6. Moving on to question 10. So we are supposed to list out a user as well as his weekly average activity distance and weekly average activity duration. And at the same time, we need to show these weekly averages for his social networks, so his followers. So in this case, we created 2 views. Let's see what's inside the first view. So here we have the user ID, username, total duration, and total distance for the user himself. For the second view, it's basically the same thing, but we just change the column names. So here is it's the same thing, but the duration and distance, we change it to total duration following and total distance following. So when we write our queries, we just match the user ID inside the second view to the follower ID in the follower following table. So we just run this. Sorry. Okay, so here's the result. We can see that for user ID 1 is being followed by 246, and the last 2 columns refers to the average activity details for his followers. Now let's move on to the implementation of our NoSQL. So this is our collection. We only use one collection with 110 documents. This is because we have 10 users and 11 activities. So we match each user to each activity. And to indicate whether this user has participated in this activity, we included a participated. If it's a 1, then it means the user has participated. If it's a 0, then he did not participate in the activity. So for the following and follower, here are the 6 arrays. The main one is the following array and the follow array. For the following male, following female, followed female, these 4 are to facilitate our extraction of data pertaining to gender. And for kudo-wise, we have 2 arrays. One is kudo given by and kudo given by followers. So basically the second one is a subset of the first one. This is also to facilitate some of our answer to the queries. So now I'll import our JSON file into our database. We just import collections, select JSON file, add file. Yep, and here it is. So now I will be presenting to you the difference between the implementation of our relational and non-relational data model. For relational data model, we have created many different entities that do not have multi-value attributes and repeating groups. Functional and transitive dependencies are also removed to ensure that the final database design obeys the 3NF rule, as shown in the ERD diagram I have presented earlier. While for our non-relational data model, since each query can only operate on one collection, and also there is no relation between collections, therefore, we have to include all the JSON documents, the required information in the collection form, which is our only collection user activity kudo follow tree. However, all these are not possible in our relational data model design. Let's take a look at example. For example, for our relational data model, we have included associative entities such as user ID, user, and kudo. Whereas for non-relational data model, we have included all the information such as user information, activity information, and kudo amount. Okay, the second difference is the amount of data included in each design. For MySQL, we have included all the entities such as challenge, clock, personal best, and weekly leaderboard, even though we may not need of them in a query writing, but we still need to keep them due to the relation and the referential integrity. Whereas for our non-relational data model, we can drop those documents that are not necessary for queries writing. So we only keep those information that are necessary. Next, I will be presenting to you our non-SQL question 5. For our question 5, how we did it was firstly we found the username, and next we found the max week, which is the largest number in our activity week column, and we find the mean week, which is the smallest number in our activity week column, and we find the total duration by summing all the activity duration across the week, the total number of weeks. And we find the total number of weeks is that we use the max week, subtract the mean week, and we sum the difference by 1. So that's how we find the total number of weeks. And we found the weekly duration by dividing the total duration which we found earlier and by the total number of weeks. And hence we set the constraint condition to be less than 30. So let's run it. As we can see here, Chen Ling, whose activity duration is 28.18, and Gary, activity duration is 9.09, and all of them are less than 30.
Now I'll move on to question 10. Question 10 wants us to list out a user's weekly average activity distance and weekly average activity duration, and also compute the weekly averages for his social networks. So first, we start off by grouping the data by username and calculating the total distance, which is the sum of the activity distance for that user, and also the total duration, which is the sum of the activity duration. We also find the max week, which is the maximum number of the activity week, and the mean week, which is the minimum. Then we create a project to find the total number of weeks by taking the sum of max week minus mean week plus 1. After that, we create another project to find the weekly distance and weekly duration of the user. Next, we unwind the following array, and remember to preserve the null and empty arrays as some users might not have any following. Finally, to compute the weekly averages for those followed by the user, we use lookup, which takes from the same collection. Using a pipeline in the lookup, we will compute the weekly averages for the users followed by the user. We first match the user ID to that of the ID from following. Then we do what we did previously to calculate the weekly distance and duration, and then save it as following details. This therefore gives us the list of each user's weekly average activity distance and duration, and computes the weekly averages for those followed by the user. So here is a demo of our code. As you can see here, Gary is following user ID 1, and these are his weekly distance and weekly duration. And for user ID 1, these are the weekly distance and duration. Now I'll move on to part 5 and discuss the recommendations to MHL. Firstly, here are some comparisons between relational database and non-relational database. Relational database stores data in tables, while non-relational database stores them in documents. We feel that when the need to store and process huge amount of data arises, the advantages of using a non-relational database can be seen, because it will be too tedious and more prone to human errors when we use relational databases, as we need to access and link data from different tables and locations. Next, due to the structure of relational databases, as we have discussed previously, through usage of foreign keys and indexes, we can access different data pieces stored in different tables. In this way, relational databases provide users a better management of heavy and complex data analysis work, as they can perform complex operations and complicated querying over the database using structured query language.
And now I will continue with our recommendation to MHL. So after comparing the trade-offs of relational and non-relational database, our final recommendation to MHL would be to use the non-relational database for this National Fitness Challenge. And our recommendation are based on consideration of the nature of data entries and specific context of this challenge. And now I will go through our first reason, because there's large amounts of data. So for non-relational databases like NoSQL, it is generally better in terms of processing data and information at a massive scale. So it is actually mentioned by the reports. Under this National Fitness Challenge, data will be collected across about 5 million citizens, and that is already database at a very massive scale. Furthermore, as MHL will be promoting the app with incentivized campaigns, and citizens are expected to use the app frequently for a prolonged period. This will further expand the database. So in this way, we feel a scalable non-relational database would be a better choice for MHL to keep records and generate further insights about the fitness and activeness level of citizens.
NoSQL data is stored in the form of flat collections and not in many separate tables. Hence, reading or writing to the collection of documents is much easier and faster. For an application like the fitness app developed by MHL, users' exercise and health data are increasing drastically daily or even on an hourly basis. Hence, there's a need for a flexible database management system. Moreover, if a new feature is added to the application and requires a change to the schema, every subsequent change would require a change to the database and an update of all the records that are already in the affected tables. Therefore, it's easier to add a new feature to the existing application by using NoSQL than SQL. If we choose to use no non-relational database, we need to take extra caution in terms of data security and keep the risk in mind as well. SQL strictly abides by the ACID properties, which focuses mainly on the security of each transaction. However, SQL follows the BASE properties, which do not ensure the consistency and security of each transaction. There is a chance that multiple transactions can take place at the same time and interfere with one another. Furthermore, NoSQL database has very little inbuilt security features in order to ensure a fast processing speed. Also, NoSQL does not consist of confidentiality and integrity attributes, which further reduce its level of security. So that's all of our presentation. Thank you for listening.